the telescope has to rotate with the Earth so that it points in one direction in the celestial sphere. And in order to actually do that back then, they had a manual astronomer that would look through a 10-inch smaller telescope to a guide star and then control the telescope manually to keep that guide star in the exact same position. So there was a lot of like manual stuff going on back in the day. The papers focus on the Palomar Observatory Sky Survey. Okay. This is POSS-1. It was a sky survey that was taken up by the Samuel Oschin telescope. There you can see the telescope itself. It's got a Schmidt camera, and this thing is specialized for wide field photography. These cameras are actually pretty insane because it has a field of view of 6.6 degrees by 6.6 degrees. Okay, so 6.6 degrees by 6.6 degrees. The full moon, for comparison, is half a degree. This is 13 full moons by 13 full moons. So it's 170 full moons big is the field of view of this camera, right? Okay. And because it's so big, the light is getting warped, right? As the light comes in, it gets warped. And so the edges of your field of view are going to get distorted.
Yep.
This specific camera is specialized for that kind of wide field photography. So it corrects for that distortion. And even then, the focal plane is actually not flat. You know how in like a camera, your CCD is basically a flat piece of equipment because all of your light is coming onto a flat piece of equipment. Here, because it's such a large field of view and it's so big, the focal plane is actually curved. So in order to get a photograph, these are all photographic plates that are used, also has to be curved. And so you got to like warp it before you slide it in there and get this photograph. I thought that was really cool.
That's interesting.
Like the amount of stuff that needed to happen in the 1950s in order to get these kinds of large field of view photographs, right?
Given the technology we had at the time.
The other cool thing is that telescope is an equatorial mount. Okay, and what that means is that one of the axes is parallel to the Earth's axis of rotation. And so all you have to do is rotate along that axis and it'll follow the stars as the Earth rotates underneath, right? The stars are all gonna move in a circle around the North Star. And so in order to track a single spot in the sky,